All right, let's talk about a material you probably touch every single day, but maybe don't fully appreciate. Aluminum. We all have a general idea of what it is, right? But there is so much more going on beneath the surface. So let's start with the big ones, the things we all know.
First up, it's lightweight. I mean, this is the obvious one. Think airplanes, bike frames, the foil you wrap your leftovers in. It's just not heavy.
And of course, it's recyclable, like endlessly. That soda can you just finished, it can become another can, and another, over and over again.
And all of this adds up to one big word: versatile. But what does versatile really mean? What's the specific recipe of traits that makes one single metal so ridiculously useful in so many different ways? Well, that's exactly what we're going to break down.
To really get why it's so versatile, we have to start with its core identity. You know, the fundamental built-in properties that are just part of what it is. These are the building blocks of its personality, if you will. Okay, it all kicks off with density. We feel that it's lightweight, right? Well, this is the science behind that feeling. Aluminum has a really low mass for its size, which means you get all this strength without all the bulk. And that, right there, is a total game changer for everything from transportation to construction.
Next up, conductivity. And this property is kind of a double threat. It's fantastic at transferring both heat and electricity. It's why you see it in high-voltage power lines. It moves electricity super efficiently. And it's also why it's on the bottom of your pots and pans, to spread heat out evenly so your food cooks just right.
And this one is just brilliant. You know how iron rusts and just falls apart? Aluminum has this incredible resistance to corrosion. It naturally forms this super thin but really tough layer of oxide on its surface that acts like a built-in protective shield. It's the reason why aluminum window frames and outdoor furniture can last for decades out in the rain.
Now, check out this number, 660.3 degrees Celsius. That's aluminum's melting point. And here's the thing, for a metal, that's actually pretty low. This simple fact is a huge part of why it's so recyclable. It just doesn't take a crazy amount of energy to melt it down and give it a whole new life.
Okay, so we've got its basic nature down, but what happens when we actually put it to work? You know, when we start pushing it, pulling it, and trying to bend it. Let's dig into that.
You know, strength isn't just one thing. Let's look at two really key types. First, you have yield strength. That's the point where you bend it and it stays bent. It's permanently changed. Then there's tensile strength. That's the absolute max it can take before it just snaps. Knowing the difference is critical if you're designing, well, anything from a car part to a skyscraper. And that idea ties right into elasticity and plasticity. Think of elasticity like a rubber band, right? It's a material's ability to stretch and then spring right back to its original shape. Plasticity is kind of the opposite. It's more like modeling clay. It's the ability to be reshaped into a new form and actually hold it, which is obviously essential for manufacturing stuff.
Now let's compare toughness and brittleness. Toughness is all about a material's ability to absorb energy and bend without breaking. Picture a metal car bumper denting in a crash. Brittleness is the exact opposite. A brittle material, like a glass window, just shatters under impact with almost no warning. Aluminum manages to find a really nice sweet spot right in the middle.
Let's look at two more ways to be strong. Hardness is all about the surface. How well does it resist getting scratched or dented? Ductility, on the other hand, is its ability to be stretched out into a super thin wire without breaking. They're two totally different properties, and they're both incredibly important for different jobs.
And finally, we have to look at how it resists the forces you can't always see. Fatigue resistance is how a material handles repeated stress over and over and over again. Think of an airplane wing flexing up and down on thousands of flights. Then there's impact resistance, which is its ability to handle a sudden, sharp blow. Both of these are absolutely crucial for safety and just making things that last.
So we've looked at all these individual properties, but here's the secret. The real reason aluminum is so versatile isn't because of any single one of them. The magic, the real magic, happens when you put them all together.
Just look at this list. This is the complete profile. When an engineer or a designer chooses a material, they're not just picking something strong or light. No, they're looking at this entire dashboard of characteristics, trying to find the absolute perfect combination for the job they need to do. And this, right here, is the key takeaway. It is the synergy that matters. It's not just that aluminum is lightweight, it's that it's lightweight and strong and corrosion resistant. That's the combo that lets you build an airplane. It's conductive
and ductile, which lets you make power cables. This interplay between all the properties, that's the real secret to its success.
And that leaves us with a pretty fascinating thought. We just built the complete profile for aluminum by breaking it down into its core properties. So as we look to the future, as we think about innovation, the really big question is this: what unique combination of properties, what new synergy is going to define the next great material that changes our world?